everyone. My name is Ahmed Ghazwani. I try to be quick and precise just because the time. My topic is about the implication of Pilates exercise in walking biomechanics and about how the Pilates will affect the hamstring flexibility. First of all, the Pilates exercise is a physical exercise program based in Control G, which was developed by Joseph Pilates. And actually, little study has been done in investigating the influence of in term of walking biomechanics and in relation to Pilates exercise. But some study found that Pilates exercise could improve the gait kinematics, such as walking speed and the step length. And with regard to hamstring flexibility, we found that most of the study, which is in literature review, they use the straight leg rising test and also the sit and research set, which are actually influenced in terms of measuring the hamstring flexibility, and it's not that much precise. So in this study, we try to use another method to calculate the hamstring flexibility in terms of Pilates exercise as well. So the aim of this study was to investigate whether the Pilates exercise would improve the physical health condition, where the objectives we collect two groups from healthy participants and one experienced Pilates with minimum 3 years experience in practicing Pilates. So we'll be pretty sure that if we got the result, it was because the main factor of practicing the Pilates exercise, and also to assess and compare between the two groups about how they work and about their kinematics result and kinetics as well. And also, as I mentioned earlier, we'll test about the flexibility mainly in the hamstring muscle. And we use a set of measurements which will be discussed later in this presentation. It's hypothesis that Pilates would improve the physical fitting, so therefore the player will have better biomechanical outcome. So we got the ethical approval, and this project was carried out in Sport Biomechanics Laboratory in Torch Center in Nine Wells Hospital in Dundee. And the volunteer was recruited by the help of poster. The healthy volunteer was in lower limb with the inclusion criteria. They should be with no lower limb injury and disability and also surgery. And both of them, they were male and female volunteer. So the measurement during the data collection, we used the FICOM motion capture system, which were used to collect the data from the participant when they are walking. And you can see here, this is the retroreflective marker, which is in the lower limb, and also the force plate, which is give us idea about the ground reaction force when the participant hit the platform. And finally, this is the test which we use to calculate the hamstring flexibility, which is knee extension angle test, as you can see here. So when the angle when you get less angle, what I can see when it go to near to the zero, that indicate good hamstring flexibility. So during the data collection, we got the signed consent from each participant before we collect the data. Also, we calculate the anthropometric measurement from each subject. We use the MATLAB program, the SPSS software used for the data analysis, and the knee extension angle, just to use directly the goniometer to calculate the angle. So when we collecting the data, we consider the subject to walk in their comfortable speed. So we take about 20 trials from each subject. So the best 3 quality of each trial were selected to be analysis. So also finally the data will be explored. There is an example, I don't know if you can see it here. It's about when the subject we're walking in the lab. As you can see here, there is a red arrow coming from the force plate, which is represented the ground reaction force, while all this thing is the marker which was attached to the lower limb of each participant after we run the plugin module. So this will give us idea and some value numbers about their kinematics and kinetics parameters while they are walking. While the knee extension angle, as you can hear, the participants were just in supine line. We try to fix his other limb, and the tested leg was in 90 degree at hip and knee. After that, we asked him to do the knee extension or to extend their leg in active position actively. So we measure this angle, and as you can see here in left side, this is the start position and this is the end position. And from the lecture review, we found that the most valid test for hamstring flexibility is the knee extension angle. So to best of our knowledge, this research was the first research using the knee extension angle in Pilates participants to test their hamstring flexibility. So let us go directly to the result. So between the two groups, the data were we have 38 subjects, and between two groups there is no significant difference in terms of the BMI, height, weight, and age as well. So we'll make sure that the results, which is outcome, are more accurate. And to be honest, the percentage of age, it was a little bit high. It was about 82 or 83 years. So it's a little bit older adults. So the gait parameter result, actually the Pilates group had significantly we found that they had higher walking speed and straight length on both sides. And also they had a higher step length and faster left foot off. As you can see in this result, they exhibit more higher walking speed in right side, and also the straight length, and also higher left straight length, and also left foot off, as you can see here. And regarding the kinematics results in the hip, there was no significant difference in the sagittal and the coronal plane, but there is a significant difference in the transfer plane. The Pilates group exhibit larger hip external rotation, and also they had more range of motion in the transfer plane in compared to the control group. While in the pelvis, we found there is the Pilates group has less oblique angle at the angle, especially at the hip, at the pelvis, sorry, in the transfer plane, which indicate that Pilates group, they had more stabilization at the pelvis while they are walking. So this maybe indicate that because the Pilates participant, they have strong muscle around in the pelvis. So about the knee, we found that in the knee, we found that the main difference was in the coronal plane. So the Pilates group, they're showing high angle in terms of knee abduction, and also they have more range of motion in the coronal plane. There was no significant difference in other two planes, in sagittal plane and transfer plane. While in ankle, the significant difference we found that the Pilates group, they have less dorsiflexion angle, and also they had higher plantar flexion angle. And in the transfer plane, they show high range of motion at ankle than control group. So now we'll move directly to the kinetic results, which is about the joint movement. In fact, the whole joint at hip and knee ankle, the Pilates group, they seems to have more joint movement in compared to the control group, which indicate they have more muscle forces around each joint. So as you can see here, and we analyze only during the stance phase, which is indicate 5 phases, like initial contact phase and loading response phase, or mid stance phase, or terminal stance phase, and pre-swing phases. And you can see here at the hip, they have significant difference in hip extension moment, hip flexion moment, and extension moment, hip flexion, extension moment in each phase, except to the initial contact phase. While in the knee joint, they shows in whole phases, in whole stance subphases, higher knee flexion moment, which indicate that Pilates group should have more muscle forces generated in anterior to the knee, which may be considered to the rectus femoris and also the vastus muscle. Finally, at the ankle, also they show higher joint moment, but only in one phase, which is the ankle plantar flexion moment in the pre-swing phase, which is considered to be the push-off phase, which is so important to have good power in the push-up phase. And it's found that in literature review, if you have good push-up power and push-up phase, that will indicate that you have more dynamic balance. With regarding the hamstring flexibility, that Pilates group show good hamstring flexibility because they have lower angle in knee extension angle in comparison to non-Pilates group. So in conclusion, that this project provide the first comprehensive assessment of walking kinematics and kinetics in Pilates participants, and it showed that Pilates has positive influence in walking biomechanics, such as they have higher walking speed and straight length, which is indicated that they have good dynamic balance and also good agility. So also the Pilates has higher angle at the knee, especially in frontal plane. The ankle and hip were in the transfer plane. Also, they showed, the Pilates group showed larger joint movements in the hip and knee and ankle during the stance phases, mainly in during pre-swing phase. So we can see that Pilates exercise from the pelvis result could help in pelvis stability, because the Pilates group show less range of motion in coronal plane. So this means that less of hip obliquity angle. So lastly, we can conclude that Pilates exercise could help improve the walking ability and also hamstring flexibility in older adults. Therefore, the Pilates exercise could be included in the rehabilitation plan. Actually, we calculate for each joint in 3 dimensions, so it includes the sagittal and coronal and frontal. But in this presentation, because the time was limited, so we share some results. Thank you so much. And anyone have any question, please just send it to me directly.
Thank you, Dr. Ahmed, for your wonderful presentation and very good research on kinematics as well as biomechanics. We'll get in
Thank
touch.
you
Please
so
to share your email address to understand more.
I
We would like to collaborate your email address and other things. Share it in the chat box.
okay
We'll be in touch.
okay
Thank you.